Assalamualaikum, hello and good day everyone. We are from group 1 consisting of 6 members. We present about what is Mendel's genetic and what are the modern crops applying to it. Let's begin with the introduction, whose pictures is in this slide. It is the pictures of Gregor Johannes Mendel, or we all know him as the Gregor Mendel. Gregor Mendel was an Austrian monk who discovered the basic principle of heredity through experiment in his garden. Mendel chose to use peas for his experiment due to their many distinct varieties and become offspring could be quickly and easily produced. He cross-fertilized pea plant that had clearly opposite characteristics. Thought that heritable factor or gene retain their individuality generations after generations. Principles of genetics developed in the mid-19th century.
Following Mendel's findings, he came up with the new word gentics, which comes from the Greek verb to generate. From his experiment, he came up with the law of segregation established that dominant and recessive traits are passed down randomly from parents to offspring and provided an alternative to the dominant theory of the time, the inheritance, and the law of independent assortment established that traits are passed down from parent to offspring independently of other traits. Throughout Mendel's experiment, he came up with the law of dominance, that means an organism with multiple forms of a gene will express the dominant form. Mendel completed his experiment with peas in 1863 and published the results in the Natural History Society's Proceedings in 1866. But his results only caught attention in 19 when rediscovered by 3 botanists independently. Mendel's work faded in and out of popularity as genetic theory progressed, but his study and theories are regarded crucial to any knowledge of the discipline, and he is therefore known as the father of genetics.
Next, we are moving to the current issues related to Mendel genetics. Presently, Mendel's laws of inheritance continue to serve as a firm foundation for modern breeding practices, which at the end of the day contribute to boost agricultural output productivity. Mendelian genetics has definitely resulted in numerous breeding advancements in many crops including grain, maize, cotton, soybean, and many more. The first issue that's stated here is Mendelizing continuous variation, specifically through the quantitative traits loci (QTL). For instance, in common bean, to identify chromosomes and detect linkage between main genes, such as seed size, or through quantitative trait linkage using a marker. Next, Mendelian genetics on plant breeding and food security. The basis of Mendelian principles develop many plant cultivation techniques like mass selection, pedigree, and bed crossing approaches, which help to improve crops to higher yielding and better quality, such as varieties of rice and wheat. According to Food and Agricultural Organization, in 2015, crop development, which is based on Mendelian principles, contributes 2,784 million tons of cereal grains to feed the world's population. Mendelian genetics principles also help in identification of grain-size genes by RepMap technology that reveals directional selection during rice domestication. Conventional techniques, on the other hand, are rate-limiting processes in cloning a quantitative trait locus, also time-consuming and tedious. So, by the application of RepMap will accelerate gene discovery and genomic breeding. RepMap technology is more efficient and effective for discovering several QTL at the same time. Lastly, applying Mendelian rules in rapeseed, also known as rapeseed, which yield rapeseed oil or canola oil. The systematic use of Mendel's rules has major influence to the advancement of many characteristics of seeds such as tolerance to biotic and abiotic stress, higher yield, and better seed quality.
Let's move to the potential future problems for current issues. Firstly, the potential future problems for rapeseed breeding is slow adoption of technological advances. Next, lack needed research development and sufficient infrastructure. Then, the potential future problem for identification of grain size, which is identification of grain size genes is the global molecular basis underlying natural variation of grain size in rice, still unclear. The last potential future problems for identification of grain sizes hinders the extensive investigations of domestication at a population level difficult to be performed.
In conclusion, the father of modern genetics is a title given to Gregor Mendel, where he had discovered the basic principles of heredity through experiment in his monastery garden. The result of Mendel's experiment showed that inheritance of certain traits in pea plants follow particular pattern, subsequently becoming the foundation of modern genetics and leading to the study of heredity that is transmitted in discrete unit. Each character is controlled by discrete unit, and there are pair, each one inherited from parents. The impact of Mendel's experiment of pea plant breeding is Mendel can develop three principles of inheritance that describe the transmission of genetic traits. Despite the lack of knowledge about the existence of genes around society at that moment, Mendel's old experiment had developed to new experiment method as the people accepted the theory of experiment and become more understanding about genetic inheritance. Furthermore, Mendelian genetics had led to many advantages in crop improvement, such as increased crop yields, reduced costs for food or drug production, pesticide reduction, nutrient composition, and food quality can be enhanced. Resistance to pests and disease, food security become greater, and medical benefit to the world growing population. The example of modern crop applying Mendelian genetics is rose breed and identification of grain size genes.
Okay, that's all from our groups about Mendel genetic, and thank you for the everyone.